In this video, we're going to review an example where we're trying to find the sample size when estimating the population mean. And I'm using the OpenStax free online textbook that you can access via this link here. All right, so to get started, let's read through the question. The population standard deviation for the age of Foothill College students is 15 years. Okay, so 15 years is the population standard deviation. We want to be 95% confident, so that's our confidence level, that the sample mean is within 2 years of the true population mean. Okay, and our question is, how many randomly selected Foothill College students should be surveyed? Okay, so let's write down what we just learned. We learned that the population standard deviation is 15 years. Okay, we learned that we want to be 95% confident that the sample mean is within 2 years of the population mean. All right, what does that mean? What are they trying to say there? Well, let's think about this. If we had a number line and we go out and we get a sample and we get a sample mean, right? They haven't done that yet, but let's just say after they do it that they're gonna have a sample mean. It's gonna be somewhere on this number line. But we don't know where the population mean is. The population mean could be here. It could be here, right? It could be really close to it, right? We don't know where the population mean is. But what we do know is that we want to be 95% confident that it's only within either 2 above or 2 below the sample mean. So the margin of error that we're willing to accept is 2. E equals 2. Okay, how many students should be surveyed? Basically, what should our sample size n be? Okay, so let's start by writing down our formula for sample size. N equals z alpha divided by 2 sigma over e squared. All of this is squared. All right. You might see that z written differently. You might see it written as z subscript c. Right? It's exactly the same thing, so don't worry about it. It's a z score. All right. I like alpha divided by 2 as my notation, so I'm going to leave it as that. But if you see subscript c, don't worry. I'm not using a different equation. It's exactly the same equation. Okay. So yeah, let's talk about that z, because everything else is pretty straightforward. Looks like we've been given sigma. They gave us sigma. It's 15, right, over here. Also, we've talked about it, and we've kind of figured out that e is 2, right? That's right here. So z, that's the guy we don't know right now. How are we going to figure that out? So z has everything to do with the confidence level. What is our confidence level? It's 95%, right? We want 95% confidence. So if I were to draw a normal distribution, right, 95% is in the middle for this confidence interval. All right, z is basically these cutoffs. All right, so in the center you have 0. So over to the left of 0 is a negative z alpha divided by 2. And to the right is a positive z alpha divided by 2. Okay. And what is alpha? Alpha is basically the leftover, right? The probability that's in the tails. Okay. So alpha, if the total probability under the curve is 1, then alpha would be 1 minus 0.95, or 1 minus whatever your confidence level is. So 1 minus 0.95 is 0.05, okay? And that alpha has to be split between these 2 different tails, right? So how much is in each tail is half of that, right? So alpha divided by 2 is 0.025, right? 0.05 divided by 2 is 0.025. So if I were to write that, 0.05 divided by 2 is 0.025. Okay. All right. Now, if I know that, I can go to Excel and I can basically ask Excel, what is this z value? All right. Because I'm going to tell Excel that the area behind that z value is 0.025, right? Because the area behind in each tail is 0.025. So let's go to Excel. And what I want to type in is equals, so let me write Z. So equals norm dot inverse. Okay, because I'm going to give it a probability. Actually, norm dot S dot inverse, because it's the standard normal. Okay, so I'm going to give it a probability. 0.025. Close parentheses, and then press enter. There we go. Negative 1.9, if I were to round that, 0.96. So this number here is negative 1.96. Right? Your z-value, you're always going to take the positive one, though. Okay, so this positive, it's exactly the same number, it's just positive. So this is the one that we want to plug in, the positive version of the z-value. All right? All right, so now I know what z is. Z is 1.96. All right, so let's see. I'm going to go ahead and plug in everything I know. Here, I have 1.96 times sigma. What was sigma? 15. So 1.96 times 15 divided by the margin of error, which was 2. All right, and square. All right, I can just plug that into a normal calculator, or I could use Excel. Remember, Excel is a calculator. Okay, so here I am in Excel. If you're going to make the effort to pull open Excel, it makes sense to go ahead and use a formula so that if you have to solve multiple of these type of questions, it makes it a lot quicker to kind of get through those questions. So let me use formulas. First, let me change this Z to being the correct sign. So a negative and a negative makes a positive. So I'll do negative there, and now it has a correct sign. Okay, so I just put a negative sign in front of the formula there. All right, then another thing that we need to know is sigma. Sigma is 15. And the next thing we need is E, the margin of error, which for us is 2. So N is going to equal, open parentheses, Z times sigma divided by, looks like my cursor doesn't want to choose that, so I'll just type in B3. You see that's where it is. It's at B3. Okay, close parentheses, do a little caret, and then type 2. All right, so Z times sigma divided by E squared. Press enter, and there we go, 216. Now, you see that 216.08? You can't have 0.08 of a person, so you always have to round this up. So the answer is not going to be 216, it's going to be 217 people. You always round it up. You never round down, because we do want to include that 0.08 of a person, but we need the whole person. So it's going to be 217 people. That's what we need. 217 people, so that we can be 95% confident that our sample mean is within 2 years of the population mean.